So we buy an ice cream and we're given some number of coins and we're given the prices. And we want to buy as much as ice cream as possible, so we want first to buy the cheapest ice creams, then a little bit higher in price, and then what was left. So the trivial solution would be to sort, but we asked to use count and sort. And that means we have to track the frequency of each price. So the frequency of 1 would be 2, because we have 2 ones. Then for the 2 it would be also 2. For the 3 it would be 1. For 0 and 5 is 1. And then we iterating from the lowest price. And we have to be careful to not to use these coins precisely. So first we have to find how many we can buy. So we take our coins, we can take our price. This is how many we can buy. And then we do this coins minus this how many we can buy, and this times the price. Let's look at the code. This was accepted Kotlin solution. I use this separate int array as a frequency counter. Use max to find the most bigger value. Let's look at some maybe shorter version, but it is already quite short. So the Kotlin's shortest one is to use group by or group B to avoid counting manually, and then it's the same code but to use size. It obviously very slow compared to what was accepted. It was 26 milliseconds when accepted, and with map it is almost 90. And then let's look at the Rust. We can use vectors and define it constant. The fastest version is to sort, by the way. We also can pre-calculate the maximum. And we can use array instead of vector to do a little speed up, but it is negligible because it is 29 milliseconds versus 26. And when we use maximum, it is optimal with 4 milliseconds. Okay, that's it for today.